The design firm of Team 16 was tasked with creating a walking Shannon robot for the client, Team 30. The client provided us with specifications to create a robot that was a variation on a classic Shannon robot. Specifically, the client outlined that the robot should be able to change its direction of motion after pushing a button and should be able to walk on preferably discrete legs. However, the client stated that should discrete legs prove too difficult, a simple ball bearing system would be suitable. Through the questions process, we were able to determine that the machine could walk at any pace. In terms of specifications, we outlined technical needs and requirements in order to determine target values for each of the customer needs outlined by the client. This led us to target values of movement for 50 centimeters, randomized direction in 3D, and utilizing 2 legs in our final design.
In order to fulfill the design specifications given, our robot needed 2 basic processes, that of locomotion and a way to determine where to move. The movement method used legs propelled by a motor to move. The direction determining method took a user input in the form of a button and chose a random number through the programming to determine the direction the robot would move. Together, these processes ensure that the robot moves in a random direction, either forward or backward, after having the button be pressed by the user. Our finished robot prototype has 6 short legs, 3 aside, connected by gears to a central motor. The chassis built around the motor is on the same level as the leg's axes of rotation, but a second level built on top of it holds the pie and the button.
During the design process, it was important that we analyzed all of the possible alternative designs. Here are some of the alternatives we considered. First, we considered using wheels instead of legs, but we decided against this due to the technical need that was given to us that they wanted the machine to walk and not roll. We next considered egg-shaped cam wheels to simulate walking. We again decided against this due to there being a lack of this shape of piece included in the LEGO kits. Another design we considered was having 8 legs as opposed to 6, although we noticed that having 6 legs already made quite a long robot and there would not be space to have an even longer robot with 8 legs. Finally, we considered having 2 sets of wheels to allow for 2D range of motion, which was originally proposed by Team 30. We ended up deciding against this due to the complexity of design needed to allow for 2D motion and this not following some of the other needs provided to us by the customers. After analyzing all of these alternatives, we decided that our design concept was optimal to successfully meet the most customer needs. Here you can see the test data that we gathered during our tests in class, and you can see that we have a consistent success in the forward and backward dimensions. The design was consistently successful in both of these, thus meeting the customer needs for multi-directional movement.
When we look at the code for the robot, the input is the button being pressed. Once the button is pressed, it generates a random value, either 0 or 1. If the value is found to be 1, the robot will move forward for 5 seconds, then stop. But if the value of the number is 0, it will move 5 seconds backwards. This is then repeatable with every time the button is pressed. This is a video of a robot moving both forwards and backwards based on the randomized value after the button was pressed. This next video is slow motion footage of the leg design in action. Thank you for watching.